My name's Matthew Mitchell. I'm studying in Trinity College and I'm studying psychology. What the musicians did when they came in was they listened to a metronome, and one of the first conditions is that they just coordinate movements up and down on this tablet to a metronome that's running at 70 beats per minute. So the second test isn't as focused on the timing. It's more a spatial component. So what the musicians were doing was they heard another metronome, but the metronome this time, it started off quite slowly and then it would speed up, and they would have to finish drawing a circle on each one of the beats. So it went from, as I say, 35 beats per minute to 120 beats per minute, which is quite high. So they were starting off here and they would hear a click and then another click, and then it would speed up and speed up and speed up. And there were 4 different conditions in that experiment, or in that test. So they would start off drawing circles towards their midline or towards their body, and then they would start drawing circles away from their midline, and then they would draw circles to the right of their midline, and then they would draw circles to the left of their midline. So the experiment is designed to see whether musicians are able to inhibit information between the 2 hands better than controls are, so people who have no musical experience. The assumption is that musicians have practiced a really rich task that should enable them to do this inhibition much better. So with musicians, I noticed most interestingly, they are good at the tempo task straight away, which is
the first one.
Yeah, which is really remarkable that they're good at it almost without any practice. And I started with the condition of giving everyone 2 minutes practice for those first tasks, and I mean, I had to do that for all the musicians, but they didn't need it and didn't want it after maybe 20 seconds or 30 seconds, which like straight away suggests that they're already better at this thing than anyone who hasn't got any musical experience. Another thing they did was they had a much more efficient control of their motor behavior. Like controls seem to be flinging their arms around in sort of a last-ditch attempt to try and get to do the whole movement cycle and to time things, especially in terms of the spatial task, the drawing circles task, because it demands more of your musculoskeletal system. I think in principle, if you haven't trained your limbs in a more similar way, if they're not trained bilaterally, then you won't have as good coordination between the hands, especially on something that's going to require motor command more than it does, say, on timing command. So that was interesting as well. I will say that we had one very young participant, and he started when he was quite old. He started his instrument when he was quite old, which, I mean, it's only one person, but it suggests that he was brilliant. He was absolutely amazing. Like, he did it perfectly almost in 2 seconds. And that was really strange, how good he was. So in that sense, because he hasn't had as much time to practice his instrument, that would suggest there might be some genetic component there.
Does that mean that this test can be sort of an indicator of musicality? Like, if you were to run this test on a small child, could you say with a certain confidence interval that this kid could well be a musician because they're naturally equipped to be so?
So it goes back to genetics and practice effects. So if a child, the way you determine whether someone would be brilliant at an instrument would be to look at their corpus callosum, which seems to be a really heavily involved region in playing music, which is best evidenced by people who have perfect pitch, who just genetically seem to have a really well functionally connected anterior and posterior part of the corpus callosum. And they also seem to have this extraordinary capacity to play music. And there's a whole lot of literature, incidentally, behind that as to why. So if you were to scan someone's brain and you found that they had a really thick anterior corpus callosum, then if you're comparing it to those people who genetically have that neuroanatomy and then also have those behavioral traits, then that would suggest some kind of correlation there. Yeah, the other caveat to sort of issue is that there's a whole lot of theories of how the brain sort of functions, and one is sort of a connectionist model, I think it's called, and it would suggest that there's no single region of the brain that is responsible for a single behavioral trait or characteristic or skill set. That there's a whole load of different regions that are contributing to this one behavioral advantage that you seem to possess over the people. So the fact that the corpus callosum is just one region that's involved. I mean, you could spend ages and ages and ages trying to determine all of the regions involved in it. So my supervisor does a thing with stroke patients called cross education, and it involves if you have an impaired limb, if you train the non-impaired limb, there'll be this phenomenon called cross education, and the impaired limb will get better if you train the non-impaired limb, which is crazy. It's amazing. If cross-education involves the corpus callosum in some way or form, and musicians perform very well on a task that involves the corpus callosum, then in theory they should be able to cross-educate that information better than someone who has none of that experience. The data that we generate from this experiment might eventually contribute to another study that you might use to investigate stroke.